You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back to another Product Thursday here on The Vocal Technologist. It is Thursday, January 22, 2026, and I got to be honest. I thought I was ready for this week. I thought, mid-January, things calm down. We'll talk about optimizing a few databases.
A nice quiet start to the year.
I was so wrong. The entire data world just woke up and decided to choose chaos this week.
It really has. It feels like we're drinking from a fire hose. I mean, we're seeing these massive acquisition numbers that just, frankly, make my eyes water.
Right.
And then there's this, genuine existential dread for junior engineers and some really big shifts in how the major players are thinking about infrastructure.
Existential dread is usually my lane, but you're right. We have a packed show. We have to talk about IBM dropping a casual $11 billion.
A very casual $11 billion.
And why your AI agent seems to have the memory of a goldfish, and this is my personal crusade, why spreadsheets might finally be dead. For real this time.
You say this every year.
Yeah.
Every single year. The death of Excel. It's your thing.
I know. But the evidence is piling up. I have receipts this time, I promise. But before my war on cells and rows, we have to start with the big one.
The elephant in the room.
That $11 billion number. IBM is acquiring Confluent.
It's just a staggering figure.
It is. And I have to play devil's advocate here. Confluent is... well, it's commercialized Kafka, right? It's data streaming. The core is open source.
You can download Kafka for free, yeah.
So is IBM just burning a giant pile of cash to buy some pipes? Or is there something more going on that justifies that price tag?
That's the exact right question. Because on the surface, yeah, it looks like they're buying a utility company, but you have to look at why now.
Okay.
This isn't about just moving data from point A to point B anymore. This is all about what people are starting to call context engineering.
Context engineering. Okay, that sounds like a term invented by a consulting firm to sell more hours. Is that a real thing?
It's becoming a real thing, and it's because of AI agents. Think about how we usually handle data. We store it. We put it in a database. When we need an answer, we query it. It's passive.
It's a history book.
Exactly. But AI agents, if they're going to be useful, they need to react in real time. They don't need a history book. They need a nervous system.
So an agent is useless if it only knows what happened yesterday.
Completely. If an AI is running your supply chain, it needs to know what happened 5 milliseconds ago. Kafka is that event stream. So IBM isn't buying pipes.
They're buying the nervous system.
They're buying the infrastructure that feeds real-time state to these models. If you control the context, you control the AI. It's a foundational play.
That makes a lot more sense. It's the difference between a paper map and a live GPS with traffic. But if context is the new gold, we're seeing other moves too, right? Like ClickHouse buying Langfuse.
This is the other side of that same coin. IBM is buying the feed.
And ClickHouse.
ClickHouse is buying the ability to see what the AI does with that feed. Langfuse is an LLM observability tool.
Observability always sounds boring until your entire system is on fire.
Right. But in this case, it's about merging two worlds. ClickHouse is all about high-performance analytics, crunching numbers fast. Langfuse tracks how an LLM thinks. That traces the latency, the errors. By putting them together, they're saying you can't separate the model from the data anymore. You have to query the AI's thought process just as fast as you query your user data.
So we're moving from asking, is my server up, to is my AI going crazy?
Pretty much, yeah. And that brings us to, the mechanics of how we keep them from going crazy. We've all been using RAG Retrieval-Augmented Generation as the safety net, but it turns out we've been pretty inefficient with it.
How so?
Yeah.
I thought IRAG is just user asks a question, we go find a relevant document, and we hand it to the bot. Simple.
That's the basic version. But think about the compute cost. If you ask a bot, what's the capital of France, and the system spins up this huge pipeline, scans a vector database, re-ranks 20 documents.
A lot of work for Paris.
It's total overkill. It's like hiring a private investigator to find out when the grocery store opens.
Yeah.
So that's why this idea of query adaptive RAG is gaining so much steam. It's basically a traffic cop. A lightweight classifier looks at the prompt first.
Okay.
Is this a simple fact? Great, send it down the single retrieval path. Is this a complex question that needs to synthesize 3 different PDFs? Okay, now you can route it to the heavy-duty multi-hop process.
So you filter the complexity before you start burning all those expensive GPU cycles.
And the results are pretty wild. People are seeing latency drop by 30, 40%.
Yeah.
But the number the CFO cares about, LLM call costs, are dropping by 50%.
50%, half the cost. That's huge.
It's a game changer.
But speaking of costs and heavy-duty tools, there's this debate bubbling up that I find fascinating. It's about vector databases. For 2 years, all we heard was, you're doing AI. You need Pinecone. You need a dedicated vector DB.
It was the default advice.
Yeah, now I'm hearing maybe not so much.
It's the classic hype cycle correction. Look, vector DBs are incredible technologies, but the real question is, do you need one for your project? The insight now is that for a lot of use cases, it's just over-engineering.
Okay, define a lot of use cases. If I have 1 million documents, I need a database.
Not necessarily 1 million vectors. Depending on the dimensions, that might only be, what, 1.5 gigabytes of data?
1.5 gigs. I have games on my phone bigger than that.
Exactly. You can load that entire data set into RAM, and if you're using standard libraries like NumPy or scikit-learn, you can do a vector search with simple matrix multiplication in milliseconds.
So why did everyone rush to buy these dedicated databases?
Because it feels like the enterprise thing to do. But think about the overhead. With a remote DB, you have to serialize your data, ship it over the network, wait, get it back, in memory with NumPy. There's no network. It's right there. It's often way faster for these small to medium workloads.
So the advice is don't buy a semi-truck to bring your groceries home.
Not until you actually have a semi-truck's worth of groceries.
Yeah.
Start simple, move to the heavyweights like Pinecone when you need persistence, or you've got really high-frequency updates, but don't start there just because it's trendy.
I love that. Stop over-engineering. That's music to my ears. But let's flip that. Sometimes you do have to engineer something complex because the problem is just that hard. We mentioned AI memory, the amnesiac agent.
This is a huge, huge pain point, especially in fields like SRE, site reliability engineering.
Right. Let's make it real. I'm an on-call engineer. It's 3 a.m. Prometheus fires an alert. CPU high. That is useless. I have to wake up and figure out why.
And a standard AI agent is no help. It'll just search the logs and say, yep, can confirm CPU is high.
Thanks, buddy.
But the fix people are building now is something called graph RAG. It combines that text retrieval of RAG with the structural understanding of a knowledge graph.
So how does that change my 3 a.m. wake-up call?
The graph RAG agent doesn't just see the text CPU high. It queries the graph of your whole infrastructure. It sees service A is connected to service B. It sees a developer pushed new code to service B 20 minutes ago.
Yeah.
And it sees that this exact pattern matches an incident from 3 months ago.
So it's connecting the dots instead of just reading the page.
Right. It drops a report in Slack that says, CPU is high because of the recent deploy to service B, which likely caused a loop. It goes from being a chatbot to being a teammate. But building that graph, that's the hard part.
Oh, for sure. Speaking of hard parts, we have to talk about Uber. Because every time I start feeling good about my data skills, I read an Uber engineering blog and feel like a toddler with building blocks.
They just operate at a different scale. It's like physics is different for them, ingesting 6 trillion rows of data every single day.
Trillion with a T. It's just absurd. But the key here isn't just the size. It's how they solve the small file problem. Why is a small file a villain at that scale?
It sounds so counterintuitive, right? But in a distributed system like S3, every single file has metadata. Who owns it? Where is it? Its size. If you have billions of tiny files, your system spends more time looking up where the data is than actually reading it. It just crushes the metadata service.
It's like a library with 1 billion books. But the card catalog is so massive, it takes you an hour just to find the aisle number.
Perfect analogy. So Uber's solution with Apache Hudi was to build their own dedicated metadata table. It gives them constant time 01 key lookups. They basically just engineered their way around the file system's limits. And they paired that with a record index that gets lookups down to 1 or 2 milliseconds. It's just incredible engineering.
And that actually connects to something else we're seeing with Spark on Amazon EMR. This myth that if your query is slow, you just throw more money at AWS.
The add more nodes strategy. It's the lazy way out, and it's so expensive. There was a great analysis this week on Spark tuning, and it showed data organization alone, not more hardware, can make a 10x difference in read times. 10 times. So I could be paying 90% less if I just tidied up my data.
Pretty much. One of the key things they pointed to was Z-ordering.
Okay, unpack that for me. I know it's a sorting method, but how does it make things 10 times faster?
Okay, so imagine you query on 2 columns a lot, customer ID and date. If you only sort by one, the other is all jumbled up. Z-ordering uses this clever mathematical curve to map that 2-dimensional data into 1 dimension, but it keeps points that are close together in 2D, close together on the disk.
So when I run my query, the engine can just ignore huge chunks of the hard drive.
Exactly. It's called data skipping or pruning. The engine knows, hey, the data for this date range definitely isn't in this blob of files, so it doesn't even look. Without Z-ordering, it has to scan almost everything. Adding more nodes doesn't fix that. It just means you're paying more computers to scan the same disorganized mess.
Paying more computers to scan an unorganized mess should be the tagline for half the industry.
It hurts because it's true. Okay, let's pivot to the business side. We saw some really cool stuff from Zalando and Faire. Zalando's is selling clothes, but the math behind it is pretty serious. They're using this RSQ replenishment policy. Now, I'm not a math guy, so help me out. How is that different from just saying order more t-shirts when we have 5 left?
So that's a deterministic rule. It assumes you know exactly how fast things sell. Zalando knows fashion is chaos. They use probabilistic forecasting, light GBM, Monte Carlo simulations.
Monte Carlo, so they're simulating thousands of possible futures.
Millions. They simulate futures where demand spikes or shipment is late or everyone returns that one ugly sweater. The RSQ policy is a set of rules that balances the risk of having too much stock versus the risk of a stock out missing a sale. They're basically optimizing for regret minimization.
Regret minimization, I like that. It's not about being perfect, it's about being the least wrong.
Exactly. And Faire, the wholesale marketplace, they're doing something similar with their recommendations. They switched to graph neural networks, GNNs, because they have a sparse signal problem.
Sparse signal, meaning people just don't click on enough stuff.
Right. If you're a retailer on Faire, maybe you only buy candles. How does Faire know you might also like this one specific ceramic mug? There's no direct link. But the GNN sees the whole graph, all the connections between all users and all products. It learns that, candle people also tend to be ceramic mug people, even if they've never interacted.
It finds the hidden bridges between the islands of data.
And the results were huge. A 26% boost in recall, which means better recommendations, and that drove a nearly 5% lift in live orders. In e-commerce, a 5% lift is a goldmine.
Oh, absolutely. Okay, let's hit the developer's toolbox. Some quick hits here. First up, this assembly line mindset.
This is a direct reaction to data engineer burnout. Teams are realizing they can't handcraft every single pipeline, so they're moving to a declarative pipeline factory pattern.
Explain declarative.
It means you describe what you want. I need this data from S3 to Postgres, not how to do it. The factory handles the code generation, the tests, the deployment. It's like a manufacturing floor for data. Every data set gets the same quality control.
I like it. Standardization. Okay, next. SeaTunnel.
Yeah, SeaTunnel is solving a very specific kind of Java hell. Class loader conflicts.
Star hell, I've been there.
We all have. SeaTunnel basically isolates these environments and uses smart metadata caching to make large-scale integration way smoother. It's niche, but if you have that problem, it's a lifesaver.
Okay, and Postgres. We always have a Postgres tip.
Of course. The tip this week is using hashback constraints for uniqueness on really large values. If you have a column with huge blobs of text, don't index the whole text. Just index a hash of it. It's way smaller and faster.
Simple, but so smart. Okay, now, the moment I've been waiting for. The death of Excel. Please tell me it's finally here.
You want this so bad. But the trend is real. People are finally using DuckDB and SQL to handle CSVs instead of just opening them in a spreadsheet.
But why now? We've had SQL forever.
The tooling got good enough. DuckDB is a single file. It runs locally. It's insanely fast. If you try to open a 5 gig CSV in Excel, your laptop just gives up.
A spinning wheel of death.
Exactly. But with DuckDB, you can query that file instantly without loading it all into memory. You can run select distinct, and it just works, and it's reproducible. You have a script. In Excel, you accidentally drag a cell, and your data is ruined with no audit trail. It's just safer, cleaner, and faster.
Safer, cleaner, faster. Putting that on the t-shirt. Excel, your days are numbered. Okay, one last tech thing. Mother Duck and MCP.
This is the dream of chatting with your data. A tutorial came out showing how to connect an AI to Mother Duck. You can just ask questions in plain English, and the AI writes and runs SQL on your private files in S3.
And it actually works.
It works. It even fixes its own SQL errors if the first query fails. It's lowering the barrier to entry in a huge way.
Which is a perfect segue to our last and honestly kind of worrying topic. If the tools are getting this good, if AI can write MySQL and fix its own bugs, what happens to the junior engineers? We're calling it the talent time bomb.
It's a crisis we are just sleepwalking into. You look at the hiring trends for 2026, and companies have stopped hiring junior data folks. The thinking is, oh, AI can do the grunt work, so I only need seniors to review it.
But where do the seniors come from if you don't hire any juniors?
That's the time bomb. We're creating a massive generation gap. And more importantly, AI can't replace judgment. We're seeing companies over-architect these massive distributed systems for tiny workloads because they don't have engineers with the intuition to say, hey, a simple script would do this for 90% less.
So we're building Ferraris to drive to the mailbox because the AI knows how to build a Ferrari but doesn't understand what a mailbox is.
That is a painfully accurate way to put it. The solution isn't more tools, it's mentorship. It's investing in humans who understand the why, not just the how.
The paradox of automation. The more you automate, the more valuable true human judgment becomes.
And that leads to this idea of data activation. The whole beta moat thing, just hoarding data, is dead. The winner is the company that can restructure their data so an AI can actually reason about it. That takes human strategy.
Wow. We have covered a ton of ground today. From IBM's $11 billion bet, to Uber bending the laws of physics, to the math of selling t-shirts, and now to the fact that we might be running out of people who understand any of it.
It's a really pivotal moment. The technology is accelerating, but the strategy is getting harder.
So here's my final thought for everyone listening today. We're talking about AI writing its own code, self-driving data factories. Are we heading for a world where we have these incredibly sophisticated software stacks that run perfectly, but no one at the company actually understands how they work? Are we just building black boxes that we won't be able to fix when they eventually break?
That is the scary possibility. If we don't train the next generation to look inside the box, we just become passengers in our own systems.
A terrifying thought to let simmer. Thank you so much for tuning in. Go activate your data. Please mentor a junior engineer. And for the love of everything good, close that spreadsheet and open a terminal. We'll see you next time.
Spoken Tech for your ears.